Hello everybody, welcome into another lesson. So today we are going to talk about two cases of special right triangles. And today's lesson is going to be super important for anyone that wants to go on to Algebra 2 Trigonometry and to Precalc and even into Calculus and beyond. Today's lesson is super important. It lays the foundation for trigonometry. So up first here, we have what's called a 45-45-90 right triangle. Well, what is a 45-45-90 right triangle? It's a right triangle, of course, meaning it has a 90-degree angle, but both of the acute angles are 45 degrees. So both of the acute angles are the same. And here we have the 45-45-90 theorem. This theorem states that in a 45-45-90 right triangle, the length of the hypotenuse is the square root of 2 times as long as a leg. So we see we have legs AB and BC. The default length for teaching this is 1 for the legs. This is telling you that the length of the hypotenuse AC would be the square root of 2, since it's the square root of 2 times either one of the legs. So you just take 1 times the square root of 2, you got the square root of 2. And I wrote the lengths here. So this is a nice theorem, and so is the next one. They're very good for helping you do shortcuts with right triangles. But these two only work specifically for 45-45-90 triangles. And then in a minute we're going to talk about 30-60-90 right triangles. But let's do some examples of the 45-45-90 triangles first, okay? These are easy enough to understand. So we're going to do a few exercises here with some right triangles. All right. Let's see here. Of course, we have a right angle right here. So the opposite sides of the hypotenuse. We have a 45-degree angle here. Then we have a 45-degree angle here. So let's see what we're given. We are given, in this case, that this here has a length of 4. We need to solve for the length of B and for the length of C. So we have a right triangle here where one leg has length 4, one leg has length B, and the hypotenuse has length C. We need to solve for B and C. Well, you can actually use in a 45-45-90 triangle, you can apply the isosceles triangle theorem also, because it would be an isosceles right triangle. So if the side opposite this 45-degree angle, this leg has a length of 4, that means that the leg opposite this 45-degree angle would also have a length of 4. So B equals 4. That's pretty easy. B is going to have a length of 4. So in these, if you're trying to find missing lengths of legs, apply your isosceles triangle theorem. That'll help you too. Now the length of C is equal to the length of one of your legs, the square root of 2 times the length of one of your legs. We'll say C equals B times the square root of 2, right? Which means it's going to be equal to 4 times the square root of 2. So the length of the hypotenuse in this case, C, is going to be equal to 4 times the square root of 2. So it's really not that bad. 45-45-90 triangles are quite easy to understand. All right, what do we got next? All right, this one here has a length of 2/3. This is length A for this leg, and then this is length C. So this time we got to find the length of this leg with length A. Well, if this leg opposite the 45-degree angle has a length of 2/3, then this leg opposite this 45-degree angle will also have a length of 2/3. So A is going to be equal to 2/3, right? Okay. Again, apply your isosceles triangle theorem, because if you have two identical angles making this an isosceles triangle, then the other leg will be the exact same length. Now let's find C. Well, C, the length of the hypotenuse, is the length of a leg. Well, in this case, we'll say A times the square root of 2, which would really equal the quantity of 2/3 times the square root of 2, which means the length of the hypotenuse C has a length of 2 times the square root of 2 over 3. So the length of your hypotenuse C would be 2 times the square root of 2 over 3 by the time you do the multiplication. All right. Let's see what we got for the next one. All right, so we have the square root of 5 for this leg. This is B, and then this is C. So we got to find the lengths of B and C. Well, both the square root of 5 is opposite a 45-degree angle, B is opposite a 45-degree angle, so that would only lead us to believe that B is equal to the square root of 5. That was easy enough. Now how about the length of C? It's always equal to the square root of 2 times the length of one of the legs. So we could say C equals B times the square root of 2, which would then give you, of course, the square root of 5 times the square root of 2, which means the length of your hypotenuse C would be equal to the square root of 10, which the square root of 10 does not reduce any further, it doesn't simplify any further, so the length of your hypotenuse C is the square root of 10. Okay, what do we have next here? I have, let's see, a few more exercises with these type of triangles. Okay, good one. They give us the length of the hypotenuse C, which is 3 times the square root of 2. We don't know the length of A or B. Well, okay, so let's start with one thing here. If the length of the hypotenuse is 3 times the square root of 2, in order to find one of the legs, wouldn't you just have to divide the hypotenuse by the square root of 2? So let's find A. A would equal, of course, the length of the hypotenuse itself, 3 times the square root of 2 divided by the square root of 2, which the square root of 2's will cancel out. A would only be equal to 3. And then since A was opposite a 45-degree angle, B also is opposite a 45-degree angle. That means B also equals 3. So the lengths of A and B are both equal to 3. And once you understand this, this can be a nice shortcut too for doing Pythagorean theorem. If you had two side lengths, that's what makes it nice. But I got, what, 4 more exercises with this one. Okay. This time the hypotenuse has a length of 6. We don't know the length of the legs. Okay, well, to find the legs of a 45, 45, 90 triangle, wouldn't you once again take the length of your hypotenuse and divide by the square root of 2? So to find the length of leg A, you'll take the length of your hypotenuse, 6, you'll divide that by the square root of 2. But we have a radical in the denominator. If we remember from Algebra 1, we want to rationalize the denominator and get rid of that square root in the denominator. So you'll multiply both numerator and denominator by that square root of 2, which would then make this equal to 6 times the square root of 2 over 2, which means A would have a length of 3 times the square root of 2. So the length of leg A is 3 times the square root of 2, which would also have to mean that the length of B is also 3 times the square root of 2, since both A and B are across from 45-degree angles. So the lengths of legs A and B are 3 times the square root of 2. That was a good one because it brought in rationalizing the denominator, which we haven't done in a while, not since Algebra 1. Alright, what's next? So, we have a length of the square root of 14 for the hypotenuse, but we don't know the length of the legs. Again, of course, you're going to find the length of one of your legs, you'll take the length of your hypotenuse. We'll start with leg A. You would take the length of that hypotenuse, which would be the square root of 14, divide that by the square root of 2, which there's a couple ways you can do this. You can either rationalize the denominator, or what I'm going to do is even simpler. We know that 14 has a factor of 2, right? If you take the square root of 7 times the square root of 2 in the numerator, you can divide that by the square root of 2. And of course your square root of 2's will cancel out, giving you the length for A just being the square root of 7, which also doesn't reduce any further. So A has a length of the square root of 7, which means B has to have the same. B would also equal the square root of 7, since both A and B are across from 45-degree angles. So A and B are both equal to the square root of 7. Alright. 2 more with these type. Okay, this time B has a length of 4 times the square root of 2. We don't know A, and we don't know the hypotenuse C. Well, we're back to the normal problems we've been doing. This 4 times the square root of 2 is across from a 45-degree angle, so is A. So that means A, by default, would have to have a length of 4 times the square root of 2. That one was easy, since A and B were the same length. Now, what about the length of the hypotenuse, C? So C, you could say, is equal to A times the square root of 2, which would equal the quantity of 4 times the square root of 2 times the square root of 2, which would mean 4 times 2, which means the length of your hypotenuse, C, would have to have a length of 8. So your hypotenuse, C, has a length of 8. Whoops, I did not mean to throw my marker on the floor. Excuse me. And one more with a 45, 45, 90. What do we got here? Okay, this time the hypotenuse has a length of 5, but we don't know the lengths of the 2 legs. So we have to solve for A and B. Well, again, to find the length of one of your legs, which would be A in this case, we'll start with, you would take the length of your hypotenuse, which would be 5, and divide that by the square root of 2. But again, we want to rationalize the denominator, so we'll multiply both numerator and denominator by the square root of 2, which means A would simply have a length of 5 times the square root of 2 over 2. And unfortunately, there's no way to reduce it any further. It's just this ugly mess of 5 times the square root of 2 over 2, which means B would have to have the same length. So B also equals 5 times the square root of 2 over 2. So those are examples of the 45, 45, 90 right triangle. Next, we're going to transition into the 30, 60, 90 right triangle, which is just a little bit harder, but not by much. So let me write out the theorem for that here. let's see, the 30 degree, 60 degree, 90 degree theorem. In a 30 degree, 60 degree, 90 degree right triangle, the longer leg is the square root of 3 times as long as the shorter leg, and the hypotenuse is 2 times as long as the shorter leg. And of course, I will do an illustration here of this theorem. So let's see. Of course, you have your right triangle. This is 30 degrees here. This one has a length of 6. This one has a degree of 60. Okay, so 1 square root of 3 and then 2. Okay. So now we have the second special type of right triangle, which is a 30, 60, 90 right triangle, which is what it sounds like. It's a right triangle having a 90 degree angle, where then you have an acute angle of 30 degrees and an acute angle of 60 degrees. The 30, 60, 90 theorem states that in a 30, 60, 90 right triangle, the longer leg is the square root of 3 times as long as the shorter leg. And the hypotenuse is 2 times as long as the shorter leg. So, of course, the shorter leg is always going to be across from the 30 degree angle, and the longer leg will be across from the 60 degree angle. We can base that on when we were talking about inequalities in geometry, with inequalities for one triangle. In a triangle, if one angle is larger than another angle, the side opposite the larger angle is longer than the side opposite the smaller angle, if that makes sense. So it would then make sense that the shorter leg would be across from the 30 degree angle and the longer leg would be across from the 60 degree angle. So here across, we're teaching this with default lengths again. If you have a default length of 1 for the side across from the 30 degree angle, then the side across from the 60 degree angle would be the square root of 3 times 1, which would just give you the square root of 3. And then the length of your hypotenuse would be literally 1 times 2, which would give you a length of 2. And now we're going to do some exercises to put this theorem into practice. Alright, so let me draw a right triangle here. This would have 30 degrees up here. This would be 60 degrees right here. Let's see what we're given. Alright, so this time we have a length of 7 here. We have a length of B here, and then we have the length of C for the hypotenuse. Okay. Actually, I did that wrong. The A, B, and C are in the, well, the C's in the right place, but the A and B I switched around. Okay, there we go. That's more like it. So we need to find the length of leg B. Well, if we notice something here, the length of this leg across from the 30-degree angle has length 7. So then the length of the longer leg, leg B, is going to be equal to 7 times the square root of 3. So it's literally, you take the length of the shorter leg, multiply it by the square root of 3, you get 7 times the square root of 3 for the longer one. So then the length of the hypotenuse, C, is literally equal to 2 times the length of the shorter leg, 2 times 7, which means C, the length of the hypotenuse, would have to be 14. So the length of B is 7 times the square root of 3, C is equal to 14. And I got plenty more examples for this. What do we got this time? So we still have to find the lengths of B and C, but the shorter leg has a length of 1/4. Well, to find the length of the longer leg, B, you're just going to take that length of the shorter leg of 1/4 and multiply that times the square root of 3, which would then mean that the length of B, your longer leg, would be equal to the square root of 3 over 4. So that's the length of leg B, is the square root of 3 over 4. Now to find the length of your hypotenuse, C, you would just take 2 times the length of your shorter leg, which would be 1/4, which in turn should end up giving you that C, the hypotenuse, is equal to 1/2. So the hypotenuse would then have a length of 1/2. So B is the square root of 3 over 4. C is equal to 1/2. All right, what's next? All right, this time we have the longer leg with 5 times the square root of 3. We don't know the length of A, and we don't know the length of C. No big deal. So the longer leg has a length of 5 times the square root of 3. The shorter leg has a length of A. Well, to find the length of the shorter leg, this time you would just take your A, set that equal to the length of your longer leg, which is 5 times the square root of 3, and to find the length of your shorter leg, you'd have to divide by the square root of 3, which then would give you that the square roots of 3 cancel out, so the length of your shorter leg, A, would just be equal to 5. So that one wasn't too bad. Length of the shorter leg, A, is 5. So then for the length of your hypotenuse, C, you just take 2 times the length of your shorter leg, which is 5, which means the length of your hypotenuse, C, would have to be 10. So A is 5 and then C is 10. Not too bad. Okay, what do we have next here? This time the length of the longer leg is 6. We don't know the length of the shorter leg, and we definitely don't know the length of the hypotenuse. So we know the length of the longer leg, which is 6. So to find the length of the shorter leg, A, we're going to take that length of the longer leg and divide it by the square root of 3. But of course we have to rationalize the denominator, so multiply both numerator and denominator by the square root of 3, which should then end up giving you 6 times the square root of 3 all over 3, which should end up then simplifying into A having a length of 2 times the square root of 3. So the length of leg A is 2 times the square root of 3. Now to find the length of your hypotenuse, C, that's going to be equal to twice the length of the short leg, which would be A, which would be equal to twice 2 times the square root of 3, which means the length of your hypotenuse, C, would have to be equal to 4 times the square root of 3. So you end up getting that A equals 2 times the square root of 3 and C equals 4 times the square root of 3. Okay, what do we got next? 4 more of these, then we'll move on to a few exercises where we combine everything. Alright, so this time the hypotenuse has a length of 10. Here's the length of A, here's the length of B. Well, this time we don't know the lengths of the two legs, but we do know the length of the hypotenuse. In this case, if you only know the length of the hypotenuse, the best place to start is with your shorter leg, which is opposite the 30-degree angle. So, it's true that the hypotenuse is twice as long as the shorter leg, right? Which would mean you'd have to define the length of the shorter leg. You'd have to take the length of the hypotenuse, which in this case is 10, and divide that by 2. Which then means, since 10 divided by 2, you have that the length of the shorter leg, A, would have to equal 5. And then now, once we found the length of our shorter leg, we can find the length of our longer leg across from the 60-degree angle. B is just going to be equal to the length of A times the square root of 3, which literally would give you that B is equal to 5 times the square root of 3. So the length of the longer leg, B, is equal to 5 times the square root of 3. The length of your shorter leg, A, is equal to 5. Alright, another good one. Yeah, I'm seeing that right. Okay. The length of the hypotenuse is equal to 13. So then we don't know the lengths of the two legs, being A and B. We got to find the length of our legs again. Okay, so of course, to find the length of your shorter leg, A, you would take the length of your hypotenuse, which is 13, and divide that by 2, which, that's what that would give you. We can actually leave it like that, or you can convert it to a decimal, or you can convert it to an improper fraction. For the sake of this lesson, I'm just going to leave it as an improper fraction. I meant you could have converted it to a mixed number, but A has a length of 13 over 2. Now to find the length of B, the longer leg, of course you're just going to take the length of A times the square root of 3, which means you're going to, for B, it's going to be equal to that fraction 13 halves times the square root of 3, which then means the length of your longer leg is equal to 13 times the square root of 3 all over 2. So that's really why I left it in the improper fraction form, since we're going to have a radical. But A has a length of 13 halves, B has a length of 13 times the square root of 3 over 2. Alright. Should just be 2 more with these ones, and then we have a few combined exercises. What are we going for this time? So B has a length of 3. We don't know the length of A or C. So in this case, we don't know the length of the hypotenuse. We don't know the length of the shorter leg. But we do know the length of the longer leg across from the 60-degree angle. Again, always start with trying to find your shorter leg in these situations. So, the length of the shorter leg would be equal to that length of the longer leg, 3, divided by the square root of 3, which we want to rationalize the denominator, so multiply both your numerator and denominator by that square root of 3, which means that should give you 3 times the square root of 3 over 3. which means the length of leg A would be equal to just the square root of 3. So the length of the short leg is equal to the square root of 3. Now you can go for finding the length of your hypotenuse, because the hypotenuse is equal to twice the length of the shorter leg, 2a, which means it's literally going to be 2 times the square root of 3. So the length of your shorter leg A is equal to the square root of 3. The length of your hypotenuse C is equal to 2 times the square root of 3. All right. The last one, we have the hypotenuse here, which is 6 times the square root of 3. We don't know the length of our legs. So we have legs A and B, A being the shorter leg because it's across from the 30-degree angle, B being the longer leg because it's across from the 60-degree angle. Then we have the length of our hypotenuse. Well, like we should always do, start with finding the length of our shorter leg. So to find the length of A, you'll take the length of your hypotenuse, which is 6 times the square root of 3. You'll divide all that by 2, which would then give you the length of your shorter leg is equal to 3 times the square root of 3. So the length of your shorter leg A is equal to 3 times the square root of 3. Now you can proceed to finding the length of your longer leg, because that would simply be B is equal to the length of A times the square root of 3, which would mean that you would take the quantity of 3 times the square root of 3, all that times the square root of 3, which would literally be equal to 3 times 3, which means the length of your longer leg would have to be 9. So the length of your longer leg in this case is going to be 9. Alright, so that's it for the 30, 60, 90. Now I have about 6 exercises here that are going to combine everything we've learned. And we'll have to do the determination. Is it a 30, 60, 90 right triangle or a 45, 45, 90 right triangle? So let's go ahead with our first example here. What do we got? Alright, so got an altitude there. We have a right triangle here, which would in turn make this a right triangle too. What else do we have? We have that this angle here is 60 degrees. This here is the length of y. This here is the length of x. In this angle here, we have a length of 30 degrees. And then this here has a length of 8. Okay. So we actually could start here now. We want to ultimately find the values of x and y. Well, here, to find x, we know that's going to be the shortest leg because it's across from the 30-degree angle, right? And the length of the hypotenuse of this right triangle is 8. So to find x, you're going to take the length of that hypotenuse, 8, and divide it by 2, which simply means that x would be 4. So x would be 4. In fact, why don't we fill that in? Because now we can actually use this to proceed to find y. Well, in this right triangle here, the smaller one, we notice that the length of the longer leg is 4 because it's across from the 60-degree angle, which means that the length of y would be your shorter leg. So always to find the length of your shorter leg y, you take the length of your longer leg, which would be 4, divide that by the square root of 3. And of course, we'll rationalize the denominator, which would simply end up giving you that you would have y equal to 4 times the square root of 3 over 3. So in the end, x has a value of 4, y has a value of 4 times the square root of 3 over 3. All right, 5 more. Okay. Let's just start here real quick. We have a whole right triangle right here, but we're not done yet. No, not at all. We know this angle here is 30 degrees. So we so far have one large right triangle split into two smaller right triangles. This would have a length of y. This has a length of x. This has a length of 6. Okay. Well, again, we want to solve for our variables. But here's the problem. We don't have any other angles identified yet. We obviously have a 90 and a 30 here, so for this right triangle, this angle here would have to be equal to 60 degrees, right? And if this whole angle here forms a 90-degree angle, that means this angle of the smaller right triangle would have to be 30, and then this angle here would have to be 60. So sometimes it does help to fill in your missing angles. Once you do that, you can proceed. So, let's go ahead here. Let's start with finding the length of x. In the smaller triangle, x is across from the 30-degree angle. Well, your hypotenuse in the smaller triangle has a length of 6. So that means the length of x is going to be equal to your hypotenuse divided by 2, since that's your shorter leg, which means that x is going to have a length of 3. Let's fill that in now. And though it wasn't asked for, you are definitely going to need the length of your longer leg, which would be here for this triangle. So the length of the longer leg would be 3 times the square root of 3, literally. Alright, because the length of the longer leg of the smaller right triangle becomes the shorter leg of the bigger right triangle. And we have the length of the shorter leg here because it's across from the 30-degree angle in the bigger triangle. Y is not your hypotenuse, it's your longer leg. Y is the length of your longer leg. So, in order to find the length of your longer leg, you're going to take that value of the shorter leg, 3 times the square root of 3, take all that times the square root of 3, which would simply turn this into 3 times 3, which means y would have to have a length of 9. So x is equal to 3, y is equal to 9. That's what you would get in the end. And these were both 30, 60, 90 triangles. It's not so much the 45, 45, 90 triangles that get people. It's more of the 30, 60, 90. Those are what get people largely. Okay, let's do something here. But we're not done yet. I butchered that, didn't I? That's okay. Alright, there we go. Let's see what we're given. This is really going to be an interesting one. So, this left triangle here, this left-right triangle is a 45, 45, 90, and it just so happens this other triangle is also a 45, 45, 90. Okay. So let's see what else they give us in this one. You have a length of 6 here for a leg of this right triangle. You have x for the length of this leg, and then the length of your hypotenuse is y. So we need to solve for x and y. Well, here's the thing. In order to solve for x and y, aren't we going to need to know the length of this leg here, which also would be the hypotenuse of this right triangle? Well, we know the length of the hypotenuse of a 45, 45, 90 triangle is nothing more than the length of a leg times the square root of 2. So the length of this leg is going to be the square root of 2. And that's opposite from a 45-degree angle, which means the length of x would also have to be 6 times the square root of 2, since if they're across from a 45-degree angle, they're the same length. Now this is where it gets fun, finding the length of y, which is the hypotenuse. We know that the hypotenuse in a 45, 45, 90 triangle is equal to the length of a leg, which in this case is 6 times the square root of 2 times the square root of 2, which would then end up giving you y is equal to 6 times 2, which means the length of your hypotenuse y would have to be 12. So x has a value of 6 times the square root of 2, y has a value of 12. And these were 45, 45, 90 triangles. I'm pretty sure in this set there's at least one exercise that combines them both types into one. And it's interesting. I just have 3 more and we're done for the night. Alright, this is going to be an interesting one here. Let's see how I draw this thing. Okay, so it goes like that. Very interesting. Diagonal here. Alright, so we have here, as it turns out, doesn't look the best, but we have 2 right triangles here. Whoops, no, I drew it wrong. I'm sorry, I drew it in the wrong place. I thought I did. We even are given that these 2 lines are parallel, which might help us a little bit. This angle is 30 degrees. And then we need the, let's see. This here has a length of 12. This hypotenuse up here has a length of 12. This side here has a length of y. This side, y, x I mean. This side here has a length of y. Okay. Well, I think we definitely have a right triangle for this top one, but before we can even proceed or have a prayer of being able to find the x and y's, we need to find the length of the hypotenuse of this triangle, which would be one of the legs of this right triangle? Well, we need to determine what type of right triangle is it. Notice we have two parallel lines. They gave us that factor, right? They gave us that. Well, you have a transversal that cuts these two parallel lines. What do we know about angles and parallel lines? That alternate interior angles are congruent. So that means this angle here would have to be 30, which all that would leave for this one here is 60. Which means then this angle right here would also have to be 60. Okay, so now we found our missing angles. That really helps us. So, the length of the hypotenuse is equal to what? Of this top triangle. It's equal to 12. We need to start by finding the length of the shorter leg. The length of the shorter leg is the length of the hypotenuse divided by 2, right? So the length of the shorter leg here would actually be 6. Now we need to find the length of the longer leg opposite the 60-degree angle, which is the length of your shorter leg times the square root of 3. So the length of the longer leg of this top triangle here is 6 times the square root of 3. Which now, interestingly enough, the length of the longer leg of the top right triangle becomes the hypotenuse of the bottom right triangle. Now we can proceed to finding x and y. Because x is across from the 30-degree angle, making that the length of the shorter leg. We know the length of the shorter leg is equal to the length of the hypotenuse divided by 2, which in this case would give you 6 times the square root of 3 divided by 2. So the length of x would be equal to 3 times the square root of 3. Alright, in fact, why don't we go ahead and write that? Because that's going to help us find the length of y. So if the length of the shorter leg across from the 30-degree angle is 3 times the square root of 3, that means y, the length of the longer leg across from the 60-degree angle, is equal to the length of that shorter leg, 3 times the square root of 3, all that times the square root of 3, which would then turn into 3 times 3, which means the length of y is equal to 9. So in the end, when you do tricks with the parallel lines and alternate interior angles, you figure out that both of these are actually 30, 60, 90 right triangles. You end up getting that x is equal to 3 times the square root of 3 and y is equal to 9. 2 more exercises, then we're done for the day. Another one here like this. I think this might be the combined one. I could be absolutely wrong though. I've been wrong before, but let's see what we got here. Oh yeah, this is a good one. You're all about to see why I'm saying that here in just a minute. So what do we got? We have that this is a right triangle, which by default this would become a right triangle also. You have this angle here is a 45-degree angle. Hypotenuse of this right triangle has a length of 8. So that would have to mean that this is a 45-degree angle also. Alright, so this angle here is 30 degrees, which could only leave this being a 60-degree angle. And then let's see, the length of this hypotenuse here is x. The length of this leg is y. Alright. Well, now we're back to finding x and y, but notice both of them are for the right triangle. So we have a 45, 45, 90 and a 30, 60, 90 right triangle combined. This is where it gets fun. So it looks to be that in order to solve x or y, we need to find the length of the shorter leg which is across from the 30-degree angle of this right triangle, which is the length of one of the legs of this 45, 45, 90 right triangle. Well, in order to find the leg of this 45, 45, 90 right triangle, you're going to take the length of your hypotenuse, divide that by the square root of 2, so then just rationalize your denominator, which would turn into 8 times the square root of 2 over 2, which would simply make this equal to 4 times the square root of 2. So now the length of the leg here is equal to 4 times the square root of 2. Alright, so now we know a critical piece of information here that's going to help us solve for x and y. Let's go in alphabetical order. Let's go for x first. Since that 4 times the square root of 2 is your shorter leg, since it's across from a 30-degree angle, that means x, being the length of your hypotenuse, is equal to the length of that shorter leg of 4 times the square root of 2 times 2. Which means x, being your hypotenuse, would have a length of 8 times the square root of 2. And then to find the length of y, which is the length of your longer leg, you're going to take the length of the shorter leg, which is 4 times the square root of 2. You're going to multiply that by the square root of 3, which means the length of your longer leg, y, is equal to 4 times the square root of 6. And the square root of 6 doesn't break down any further. So the length of x is 8 times the square root of 2. The length of y is equal to 4 times the square root of 6. So this was a fun one. We had both types of triangles combined into one. And I got just one more problem, then we're done. Okay, what is this one? Let's see what we're given here. We're given that these two lines are parallel, so that'll help us. This has a length of 6. We have a right angle here. This has a length of 4. Alright, this whole side has a length of x. This is 45 degrees here. This has a length of y. So we have a fun one. Well, here's what we're going to do. First thing we need to do, well, alright, let me put it this way. The length of this whole segment here is x. So the length of this entire side is equal to x. So what we need to do then, it almost looks like we have a right triangle and a rectangle combined, right? So let's go ahead and do that here. Let's draw an auxiliary line to form those two shapes. If we draw the auxiliary line, you now have your right triangle here, and then of course you're going to end up having your rectangle. We know that this shape here is a parallelogram because you have opposite sides being parallel and then congruent, and then you have the rectangle aspect because they're all right angles. Okay. Well, we know the length of this side of the rectangle is also going to be 6, right? Which now means that the length of this side of the rectangle would have to be 4. which also, this length of 4 happens to be a leg of a 45, 45, 90 right triangle. So, that would leave by default here that the angle here in this right triangle, missing one here, was also 45, right? If the length of one leg from a 45 degree angle is 4, that means the length of this leg here is also 4. Now x was the length of this whole segment, so x is equal to nothing more than 4 plus 6, which means x would have to equal 10. So we found the length of x to be 10. Now let's find the length of y. Well, the length of y is the hypotenuse of this right triangle, isn't it? We know the length of the hypotenuse of a right triangle, which is y, is equal to the length of a leg, which would be 4 times the square root of 2. So, the values of x is 10, and the value of y is 4 times the square root of 2. Now that's it for this lesson. Next 3 lessons we are actually going to do some very, very basic introductory trigonometry. Next lesson itself will be about the tangent ratio. We will talk about strictly the tangent. So I hope everyone has a great night. Take care.